Well, hello everybody. Welcome to our webinar. Today we are talking about apex locators, pretty much apex locator, working length determination using the electronic reading with apex locators. Unfortunately, Dr. Miyazaki was not able to join us in this webinar, but probably next webinar, Dr. Miyazaki will be with us. So let's go forward without Dr. Miyazaki. We know that the working length determination is one of the most important procedures that we have to do during our root canal treatment. Pretty much what happens is you are going to determine two things. You are going to determine the cleaning limit, and you are going to determine your obturation limit. So basically those two limits, pretty much they don't match. They need to be a little bit different one of the other. And we are going to discuss that. But essentially, the working length determination should be exactly after you scout the canal, after you pre-flare the canal. And this is very important. First takeaway is try to pre-flare the canal first. And I will explain later why this is important. So you can use an apex locator, you can use a motor with an apex locator like the ACE, for example, but the electronic procedure, the electronic reading will be pretty much the same if you're using a motor with apex locator or an apex locator alone. So this is one of my publications. I published this in Dentistry Today back in 2017, I guess. And this is where I explain exactly why we have to do, or why we have to have two apical limits. The first apical limit that we have to have is the cleaning limit that goes exactly to the foramen position, the foramen exit position. Back 1 millimeter, 0.5 to 1 millimeter, you have the apical shaping limit. So let's start with the apical cleaning limit. To be able to remove all debris that you produce during your cementation, or even to make this canal to the foramen exit patent, meaning free of debris, you have to determine the foramen position first. And if you go to the glossary of endodontic terms, you can see that apical patency is a technique where the apical portion of the canal is maintained during your whole instrumentation, during your whole irrigation, free of debris by recapitulation of a small file. And this is very important because this file, from apical patency standpoint, needs to be a small file or smaller than foramen. And you know that foramen, usually the smallest foramen, anatomically speaking, is about 0.25. So 0.25 is the smallest diameter without any pathology, without any calcification. This is the smallest main foramen diameter that you can have. And it's pretty much a 25 file, right? So if you use a 20 or a 15 or even a 10, you are always not doing any deformation on this foramen, but just keeping this foramen patent, or meaning free of any debris, right? There are a lot of exceptions. For example, not all canals has a main foramen. Many of them has lateral axes or little foraminas that just spread on the apical terminus of the canal. There are lesions, apical lesions, that guides or leads to resorptions, and these resorptions can deform the design of the foramen, pretty much opening this foramen to a 0.4 or 0.5, sometimes millimeter diameter. So there are a lot of exceptions, but by the rule, the smallest foramen possible is around 0.2 nt to 0.23 to 0.27. So apical patency is nothing more, nothing less that keep that area free of debris. And you have to go with the tip of your file to the end of the canal. That means the foramen exit. So the end of the root canal is not the apical constriction, and we are going to talk about apical constriction as well. It is not the CDJ or whatever, it is the foramen exit. So there's a terminology called foramen equator. So this foramen equator is a line that it is exactly in this point here, right? That will show you exactly where is the limit of your foramen, or where is exactly canal exit or the canal terminus, right? So one of the papers that I think that is extremely interesting is this paper from Young that was published in Australian Dental Journal. I use this paper a lot in my lectures because the results of the review of literature that they did with Dr. Messer as well was teeth in which endodontic instruments were unable, not able to reach the apical foramen had 5 times increased risk of failure than the other cases with accessible foramen. So it is very, very important that you determine the foramen position by putting the file at the foramen exit. And you can do that using your apex locator. Coincidentally, and very good for us, this is the most reliable part or point of your apex locator reading. Meaning that if you find the foramen exit, your apex locator will give you a more reliable position. And the difference in that position by the studies is less than 0.5 millimeters. So basically, the foramen exit is the most reliable point. And just as a takeaway, try always to find the foramen exit. It's the 0 point in your apex locator. So by definition, there's new and old definitions, right? New and old concepts. So by definition, you have the foramen, that is the foramen exit here. And this is a SEM, electronic scanning microscopy image. So you have the foramen here. And because this image was made by cutting the very end, one of the walls, exposing the canal wall, you can see that this area here, for example, this is just a projection of one of the walls that was left there. Of course, you cannot see these little details or little projections that remains, but when you see under the microscope, you can see that is a big projection here. This is not part of the canal. Behind this little projection, there's the canal there. So most of the time, when you do a histologic access or a histologic view in one plane of the root canal, of the root itself with the root canal, you have this second thought of, wow, this is a big constriction that we have here. And in the past was recognized as constrictions as well. So you have the radiographic apex, and this is the point that I'm talking about. This is the point that should be a constriction, or in the past, people recognize this as constriction. We are going to talk about this, but all that projection is not true. Today, with the CBTC, we can see in the CBTC, and depending on the software that you are using, this is from Dr. Mike Bueno from Brazil with Dr. Estrela. But as you can see here, you can see exactly the position of the foramen in incisors, anteriors, or even posterior teeth, right? So this is a real in vivo image of a patient that is under CBTC image XM. And you can see here the real position of this foramen on the buccal and palatal roots. So this is extremely interesting by the fact that you can see a little bit better. But if you see the latest publications from Dr. El Ayut, so Dr. El Ayut start to see and study by micro CT or microcomputer tomography in extracted teeth, the position of the constriction. First, he was trying to see, okay, so is there constriction, apical constriction or not, right? So he classified constriction form traditional, meaning this here, versus, and honestly, I don't understand why he said in this way, constriction form parallel. So if you have a parallel exit, you don't have constriction at all, right? So it's just one wall coming, another wall coming, another, and then foramen exit. So in my opinion, he put constriction form parallel, just not to create a lot of buzz, but this is, in my understanding, no constriction and constriction, right? So let's see the results. So all the canals, 10% has the constriction form traditional, and 76% in form parallel or tapered, meaning just 10% in this study show some sort of apical constriction. But look, he came with more and more data on this study, and he shows something that is very, very interesting. In the beginning of our webinar, I was talking about the diameter of the foramen, and a lot of people most probably were thinking, well, this is too much. How about those 10 files that barely can go there? Well, most probably this 10 file is touching another part of the canal and then giving you this sensation that is at the very end. Or, of course, in a calcified canal, the game is totally changed. But in these cases of Dr. Elliott, look, average, this is a number 25 space or 0.25 millimeters space in red. The two lines in blue is number 30. And look the average of the apical foramen is between 25 and 30, or even borderline with 30. So the red and blue lines represent endo instrument size 25 and 30. So the most common form of constriction was the parallel form, or no constriction at all. The traditional constriction with canal pre-flaring apically and coronally from the constriction was present in just 10% of the canals. And the size of the constriction, meaning foramen, in molars corresponded to instrument 30. But Dr. Elliott shows more papers after that, because the results were so amazing that he said, well, let's study a little bit more under micro CT. And he discovered another very interesting thing. It depends on the level of the layers of the image that you have. And pretty much not only that, but it depends on the side view that you want. So in longitudinal views like this one, this is the same canal. And I bet that you are saying, wow, this is a beautiful apical constriction. If you go 1, 2, 3, 4, 5, 6, 7 layers down, there's no constriction at all. Of course, this is just a projection of the buccal or the lingual wall that is start to showing on those layers. And of course, if he goes up to these layers, this constriction will go more constrict until it closes, right? Of course, because there's the buccal or the lingual walls, layers coming through, right? In this is the segment that you have to see, because this is exactly in the middle. So there's no projections of the buccal or lingual, and you can see there's no constriction at all, right? Another thing is when you do not longitudinal, but when you do cross sections, and when you see the cross sections, that is unequivocally you can. So if you see the cross sections, there's no doubt that the apical constriction is not there. So this again, this is one of the part of the papers. And if you see the difference between when you see traditional 30% of the cases show the traditional constriction in longitudinal sections, but when you see under cross sections, just 13, right? So not only those canals has a very little percentage of the traditional constriction, but the way that you see, the way that you do your study is extremely, extremely important, okay? So let's go back. So the foramen position is the most important for us. Determining the foramen position is the first step to determine your apical cleaning limit. And 0.5 or 1 millimeter off, that will be your shaping limit. That will be when you're going to enlarge a little bit this canal, creating a convenience form or a convenience design to keep your obturation under control, especially your gutta percha point. So this is where you create this niche or this design so your gutta percha point, and especially the gutta percha 04 or 06, they will adapt exactly at that little niche, that little apical area that you created enlarging with your files. So that is where is extremely important to determine the diameter first of this. But for being able to determine the diameter, or let's say the working length or the working width, so to determine this working width, you have to determine the first file that will adapt exactly in that point. And without pre-flaring, you cannot do that. Even most of times when you do a very good pre-flaring, even in these situations, if it is a curved canal, you can feel the first file adapt, but most probably it's the body of the file that is touching the curvature inside the curvature, the flattened area inside the curvature. But anyways, it's better than nothing. So pre-flare the canal first, and then put the files in sequence. K file, stainless steel file, could be K file, could be flex file, but you have to determine the first width, that is the diameter of the canal, before doing your instrumentation. So the apical shaping limit is exactly to create this area that will accommodate, that will stop your gutta percha cone of going through the foramen to the periodontal ligament, periodontal bone. So where is the foramen? So let's see where is the foramen and how to determine. So back in my time, we used to use the D-speed. Back in my time, we used to use the D-speed X-ray films. And the D-speed has these very nice contrast and very nice detail, even though we don't use D-speeds anymore because D-speeds were double of radiation, and to make the patient a little bit safer, then we use the active speed or the E-speed that is way faster. But faster doesn't mean better in terms of the type of image or details. This is a D speed, but even with this D speed, you cannot see the foramen here. You can see the canal here, you can see the canal there, and after that, you don't see anything. According to Dr. Gutman, and he came with this statement that is awesome. He said the real anatomy of the apical part of the root canal can be determined after your obturation. And I will just say something else. After your obturation, if you're able to keep pattern and clean the foramen exit as well. So, by the way, I was not able to keep a good foramen in this particular situation here in the mesial root, but in the distal root, I was able, so you can see the foramen exit is totally not apical. X-rays are awesome, and they made our specialty endodontics real. But there are so many limitations, and especially when you talk about working length determination, the X-rays and the files inside are very complicated. Look, this case, I cannot see anything either in this one. So this is the thing. You fear what you don't control. You fear what you don't see. You fear what you don't understand. And this is pretty normal in the human being brain, right? So because you cannot see the apical terminus of your instrumentation, you don't know if you're being short or if you're under the bone or if you're trespassing or not. So that is the stress that comes in the middle of your operative procedure, that is right before the instrumentation. So if you do your instrumentation with the fear that you don't know where your instrument is in terms of the apical terminus, it will be very, very complicated to keep your instrumentation fluid and easy to go. You're going to be always with the thing, am I short? Am I going through what I'm doing here? And you do fast, and when you do fast, and when you are stressed and fast, most probably you have more probability to break a file. So the working length determination needs to be, I would not say 100%, but needs to be as in a high, accurate, and precise manner possible to give you peace to do your instrumentation, to do your obturation without any fear. Of course, this is other image. Those are X-rays that I collect in 1 week at school, at the university. I was a faculty member at the university, and I just collect this in less than 1 week, and I put in my book about working length determination because it was like a day-to-day situation on the clinic with students. And basically what happens is not accurate. So if you see when you project a file that is passing through the foramen 1 or 2 millimeters by the X-ray angulation and by the film angulation inside the mouth, especially upper mouth, especially upper teeth, you are going to see some shadows and images that doesn't match with the reality. So this is another one, just showing the foramen exit, very lateral foramen exit, by the way. It is passing here 3 millimeters, and in the X-ray, it is totally in. So it is very hard. Those are the real third generation devices, apex locators. This is the APIT or APIT from Osada, and Index was the second name that they put on the same equipment. Those were pre-Root CX, by the way, and they are so-called third generation because they use in this case, 2 frequencies. We have equipment that use 5 frequencies. I have a pattern of the whole spectrum of frequencies. So basically, I will explain how this apex locator works. This is our pattern on the, it's called radicular spectral attenuation coefficient for use in endodontic foraminal locator, because it is not an apex locator, it's more a foramen locator. So basically what happens in an apex locator, and a lot of people do a lot of confusion on that, thinking that is positive and a negative, nothing to do. Basically, what happens is taking advantage of the fact that dentin is an isolator, and this isolation, electric isolation and thermic isolation as well. So it depends on the thickness of dentin. So if you see the thickness of dentin just get thinner and thinner and thinner only at the very end of the root. So if you take the cervical middle thirds by anatomy, they have this 2/3, they have pretty much the same thickness of dentin, and is getting thinner, thinner, thinner just at the very end, 4 or 3 millimeters of the foramen. So the first thing that you have to understand is never try to do your working length determination coming from the cervical, and then the middle third. Just put your file at the very end of the middle third, is so-called the temporary working length, and then plug your file clip. Don't try to do it with your file clip since the beginning, because it will just create a mess, right? Put the file, clip, file clip, and then use your working length determination or your apex locator. So this thickness of dentin is very important because we isolate the passage of the electronic signal. There's a difference between electric current, that is DC, and AC, that is electronic signal. Electric current is positive and negative. Electronic signal is a different thing, right? So we are going to use AC, not DC, and we are going to use electronic signal, not electric current, okay? So let's try to understand what happens. So an apex locator turns from DC to AC by a transformer that is inside the equipment. And then this current, or this electric current, change to electronic signal. That is pretty much something that you can do a very good measurement. So basically what the apex locator will do is to send a electronic signal through a cable that will be attached to a file, right? And this electronic signal will start from inside your equipment, going through the cable very fast, through the file very fast, and will stop at the very end. Definitely will stop and accumulate and accumulate and accumulate all the electrons coming, and all of a sudden you have one spark, poof. Then more electrons are coming, and another spark, poof. And another one, and another one, and another one. The number of sparks is the frequency. So you can change this frequency for a low or high frequency. And low and high frequency together will give you a better perspective, like a 3D perspective where the tip of the file will be. So basically, you have to understand that the tip of the file is the most important part. Because if the tip of the file is loose inside the canal, this passage of the electric signal will be jeopardized. So that's why it's very, very important that you use a file that the tip of the file matches, at least touches 2/3 of the dentin walls. Why? Because then you have a better signal going through dentin and coming back to the equipment. You know those readings in the apex locator that is in and all of a sudden disappear and then goes in as well and then disappear. This is why or when you have the tip of the file not touching all the walls, or you're moving too fast. So if the file is loose inside the canal, you move too fast. Doesn't give the apex locator the right time to process everything and give you, well, you are in this position far from the foramen or very close to the foramen or at the foramen. So basically, not only you have to use the right tip, but you have to use the right movement as well. Be careful, gentle, and just go very slowly with your file touching the walls. Feel the file going through, and step by step, little by little, you are seeing the results on your apex locator. So I will send a signal right now. So I start the signal from my apex locator. This is the output signal, and then go stop, gives this sparkle, and then what happens is, because I have a thick dentin, it will be hard to pass through, and then will come as an input signal back. So let's say that I send 10 bananas, not bananas of course, but I send 10 bananas through here, and these 10 bananas I will lose 1 and 2 and 3 bananas, and just 7 bananas go back. So this is some sort of the impedance measurement that we do during this process. The impedance measurement is how the dentin can stop the passage of the electronic signal, right? And of course, if I have this thickness of dentin, will be hard to the electronic signal to pass through than if I compare with a little tiny thickness of dentin. So if I put my file down a little bit the canal and I do the same thing, look, the signal will pass a little bit easier, a little bit faster. Instead of losing 3 bananas, maybe I lose just 1. And then go back. Wow, your apex is saying, wow, I sent 10 bananas, I'm receiving 8 bananas. I just lost 2. So maybe this is around 1 millimeter of the foramen. But it's very, very unprecise. The numbers before, even the 0.5, very not precise, very not accurate. Okay? So the place that is the most accurate place is the foramen exit. Then I send my signal, I send my 10 bananas there, and I receive 9.99 bananas back. So wow, apex is, wow, I'm so close to the foramen that I'm pretty sure that I am there. Because the thickness of dentin is so little that it's not able to create any important value of impedance. So here, as you can see, I'm going with the tip of my file to the 0. So the 0, the last bar here, will be the most accurate point. If you are doing with the ACE, for example, that has an apex locator built in, then will be the last orange point here and the number 0, 0. That is the most reliable point, and you determine the apical cleaning limit. 0.5 or 1 millimeter off this will be your shaping limit. And your hand file number 10 or number 15 will go always go to this length to make sure that all this area will be free of debris. So another thing, again, I already said, but I will rephrase. It is very important that this file is not loose inside the canal. If it is loose, you have to change for a 20, 25, even a 30, because the file needs to be touching dentin walls. And this is very important. At least 2/3 to have good passage of the electronic signal. So some things can happen during the electronic measurement. And one of the things, the most common, is I put my file, I stop with this file in a limit, and then after that I cannot go through, right? So what's happened? Most probably, this file is touching the final part of what we call the anatomical canal, and the foramen is a 90 degrees exit. Especially molars, some premolars as well, you have this 90 degrees exit or 60 degrees exit. Your file cannot follow to the foramen exit, and then we'll stop 0.5. Take an X-ray and take a look and see what's going on. Another very important thing is, of course, rubber dam. Without rubber dam, there's no endo, period. If you are not able to put a rubber dam, don't try to do the endodontics. Don't try to do the root canal treatment. And even when you put the rubber dam, the isolation, you have to complete this isolation with some kind of gingival barrier, right? So there's many of them in the market. Some are light cure, some are not, but doesn't matter. What matters is try and be sure that there's no communication between gingiva, between inside the mouth and your access here, because this is very, very, very important for endo and, of course, for electronic determination of the working length. If you're not able to see the crown, there are so many ways. There's laser, there's surgery, electric surgery, or laser, or you know, even a burr in high speed can do at least a temporary crown length, and then you can install your rubber dam. So there's no excuse at all. So let's see in this slide how we have to do. So I will put my number 15 file to my temporary working length, and then I will install my file clip and gently going to the apical area until 0. I mark this point with my rubber stop, open a little bit of space, remove the file, and use my ruler. Using the ruler, the endodontic ruler, I will see, let's say 20 millimeters. 20 millimeters will be my cleaning working length. 19.5 or 19, depending on your technique, will be your shaping working length. And then after that, of course, you will always go to your apical shaping limit with your big files in sequence, and in between, use your small file number 10 or 15 to provoke the patency and clean, and make sure that you have that little segment of 1 millimeter free of debris. This is the end of our webinar about Apex locators. But if you have any question, just email me at carlos.ramos@medidenta.com. And don't forget to see the other webinars and videos that we have in our website. Just go to www.medidenta.com. At the homepage, scroll down to events, webinars, and shows, education. Then you have all the webinars here, the endotechnics part 1, endotechnics part 2, the Q&A webinar, new approach of root canal disinfection part 2, part 1, and of course, videos about endodontic techniques. Okay? Well, thank you very much. And I'm looking forward to see you in our next webinar. Thanks.